let's look at another question. This is taken from JAMB of 2002. The pressure of 3 moles of an ideal gas at a temperature of 27 degrees centigrade, having a volume of 10 to the power of -3 meter cube, is what? Question. Where R is given as 8.3 joule per mole per Kelvin. So just know that R stands for the universal gas constant. Okay, so you are given number of moles, you are given a temperature, you are given a volume, you are given R. Solving this now, N is the number of moles. That's N is the amount. So N is 3 moles. The pressure we are looking for, so pressure is left as question mark. Volume is 10 to the power of -3. Okay, and that is 1/1000. Okay, standard phone number. So we have that, which is this. Then the temperature has to be converted to Kelvin. From Celsius to Kelvin, you simply add 273. So don't forget that number, 273. So R is the universal gas constant. So it's usually given in the question. You don't have to memorize it, but you could. 8.3 joule per mole per Kelvin. So apply the ideal gas equation. You break it down, you have that as well. So let's look at another question from JAMB of 2008. A sealed flask. Okay, flask is sealed. That means the mass is constant. Contains 300 centimeter cube, okay, of air at 27 degrees centigrade and is heated to 35 degrees centigrade at constant pressure. So you are looking at volume and temperature at constant pressure. So that should tell you that should be volume and temperature at constant pressure should follow Charles's law. So quickly, just the first thing is to put in the values you are given in the question. Okay, V1 like that. Make sure you convert Celsius to Kelvin. Always convert it to Kelvin. So you put in the values you are given. Okay, so V1 over T1 is equal to V2 over T2 continuously. That is Charles's law. So V1 is 600 in the question. T1 is 300 Kelvin. So put it V2. We are looking for V2. Leave it as it over T2. T2 is 308. So V2, if V2 stands alone, that's make V2 the subject of the formula. 308 comes up here like you're cross multiplying, right? 308 comes and multiplies 600, while 300 remains down as a denominator. So by the time you punch this in your calculator, you have that the new volume V2 is 616 centimeter cube. Okay, let's have a quick recap. Remember, Boyle's law says the product of pressure and volume is constant. Okay, Charles' law says volume is directly proportional to temperature, so that's absolute temperature. So if you arrange it, becomes V over T equals constant. And Gay-Lussac's law, or the pressure law, says also pressure is directly proportional to absolute temperature. So if you rearrange it, P over T is equals constant. Now, in the exams of JAMB 1993 and NECO 2009, a question like this came out. The solution is as follows. This equation, look at this is where the question is. Equation P power X, V power Y, T power Z equals constant is, okay, so I have 3 different answers. Okay, so I have A. This equation is Boyle's law. If PV equals to constant, so T has to disappear. Or okay, so how do we achieve that? So X should be power 1, Y should equals to 1, and Z should equals to 0. Remember your law of indices: P power 1, V power 1, T power 0. Remember, T power 0 will just become 1, so it becomes just PV appearing. Then how is this equation? How is this equation Charles' law? How can we reduce this equation to Charles' law? Okay, Charles' law has just as volume over absolute temperature, right? So volume over absolute temperature. Now remember, V over T can be written as V times 1 over T. Okay, V over T can be written as V times 1 over T. So basically, we want this expression, P has to disappear somehow. So it becomes P power 0, V power 1, T minus 1, and then see how that goes. So how can this expression, this equation P power X, V power Y, T power Z equals constant, how can we reduce it to be Gay-Lussac's law? So I'll leave that for you to do right now. Remember, Gay-Lussac says pressure over absolute temperature is constant. So basically, they want a value for X. So say P X, I'm writing down the original question. P raised to power X, V raised to power Y, T raised to power Z. So we know that P should be 1 raised to power 1. V has to disappear as raised to the power 0, that's v raised to that, all of that's 1. Then t should be a negative 1. So it becomes pt minus 1, which is p over t, which is our constant, okay? So basically, x, the answer should be x equals to 1, y equals to 0, and z equals to minus 1.